Good morning. Today we're going to talk a bit more about MySQL InnoDB Cluster and the new released MySQL InnoDB Replicaset. So I'm Kenny Grip. I'm a MySQL product manager responsible for high availability at MySQL. So let's think a bit about what the past, the present, and the future of MySQL. And in the past, when we think about replication topologies, everything was manual. So what MySQL did is MySQL released MySQL with replication, but then it was up to the user to set up this replication itself. And many steps were required for the user to set up replication. For example, when a user wanted to add a replica, a backup had to be restored. A user had to be created on the primary. Configuration of replication had to happen. Replication had to be started, and so on. This is just to configure the replication topology. Then when the user wanted to make topology changes, more steps were required to do this. So there's a lot of things, and what MySQL did was offer the technical pieces and then giving the user the flexibility to set up its own architecture, which is very powerful. And this is that a lot of users of MySQL to create very creative or have a lot of like scale out, multiple tiers of replication, various different ways of doing kind of failover when something went wrong. So a lot of things were responsible by the user. And this basically ends up that every setup of MySQL replication is kind of a customized architecture up to the user. And a lot of these components that MySQL provide, well, you have to understand them. And a user of MySQL had to like know what all these things mean, knows how to set it up, or rely on external tools not built by MySQL to set up and do all these kinds of operations. So a lot of work is there by DBAs and experts or consultants. And a lot of the work there is automation and configuration of just this replication topology. So in 2016, MySQL InnoDB Cluster was released, built on Group Replication. So we have Group Replication that is a replication, new replication way, well, new since 2016, which brings you a lot of things that are now automatic. So automatic adding and removing of members, automatic network partition handling. There's guaranteed consistency across all members. You can change memberships, you can change the primary as needed, and the group will take care of that. So the technology will provide you with that. Additionally, as part of InnoDB Cluster, you have Shell, and Shell is this interface where you can connect and do all kinds of things that you had to write your own automation for in the past. You can set up a cluster and you can add and remove members all automatically with a single command. So setting up MySQL InnoDB Cluster is very easy. It's just a matter of like 5-6 commands and you will have a cluster up and running. Another thing we released last year in 2019 was Clone, part of InnoDB. And this is a way to automatically provision members in the group and have it fully integrated in MySQL and in InnoDB. So meaning that if you want to add a member to the group, you basically start MySQL, configure it to join the group. Shell will do all this for you, but it might not have the data, and the other members will be able to provide that data through Clone. So it's a physical snapshot will be provided to the member that is joining online. So read, write operations still continue. Only DDLs are not allowed during Clone. And this makes it very easy, and it's using MySQL connections over port 3306. So authentication is handled, security is all handled. So there's no need to rely on some external backup tool to take a backup, spool it through the other member, do a lot of automation scripting around it to make this happen. So it's all fully integrated in InnoDB Cluster. Now in 2020, in January 13th, we released 8.0.19. And this is basically providing a lot of the functionality that we have with group replication in InnoDB Cluster and bringing this to replication. So asynchronous replication, as many call this, and make it a solution. So taking the replication technology, the components with MySQL, take Shell, use InnoDB Clone, and have a way to configure replication. And today I'll talk a little bit about both of these solutions and dig a bit deeper into InnoDB Replicaset and what it is and what it does and what it does not. But first of all, let's go to 2016 and where we launched InnoDB Cluster. And MySQL InnoDB Cluster is a single product, MySQL, built by MySQL, and it provides you with high availability, some scalability features, and an integrated end-to-end solution that is easy to use. And this ease of use is very important in this product. And so we have these 4 components, basically. We have MySQL Server. So on the bottom, you have Group Replication. In this example, we have 3 database servers. And Group Replication is configured between all these servers. So it's a cluster of 3 members. Each database server has the full data set. So Group Replication is a way to replicate data. It is not a scale, does not put data and spread data across multiple members and achieves like a sharding or write scalability. This does not do that, but each member has the full data sets. We have a lot of guarantees there, and I'll go a little bit deeper in the next section on group replication. We have MySQL Shell, which is this interface, this shell that you can use to configure all of these things. And then we have MySQL Router, and Router is kind of the gateway from the application to the actual data. And Router will redirect to the appropriate group replication member. When any topology changes happens, Router will adjust and transparently move this connection to or new connections to other group members. So let's go and see what is the actual goal, right? So it's one product, and very important is that all of these components are developed together. So we have the various teams in engineering working on replication, then you have teams working on Shell, on Router, and so on. But this is all built by MySQL, driven by MySQL, and integrate everything. All these components are completely integrated. We also do testing of this full product. So we have some limitations in the flexibility that you can do with this. However, we do this because we are doing QA on everything we support. So that's a very important thing. Ease of use, very important. We have MySQL Shell that is the client to do it, to configure all this. It's very modular. You can make a lot of your own automation in there. So it does all these things built in. And I'll show you some examples. And then third is we have group replication. So for group replication, what is it? It's basically a highly available distributed MySQL database. So what it gives is fault tolerance, automatic failover. You can configure it in multi-primary mode. So the default is single primary mode, where there's one member available for writes. And in multi-primary mode, multiple members are available for writes. So you can write to all database servers at the same time in that case. There are some limitations related to cascading foreign keys, for example. But you can write to all members, and there is a guaranteed consistency. There will not be any data loss. So with asynchronous replication, classic replication, you do have these problems when you write to multiple members at the same time, because replication of the data is asynchronous. There's no built-in conflict detection and resolution in replication. But group replication brings all that. It brings this conflict detection, resolution. It brings this automatically adding and removing of members. It handles network partitions. It handles failures, all automatically. So it is an implementation of a replicated database state machine. And what is important is that every write in the whole group, so regardless on which node is doing the write, is ordered. So there's a total ordered in the whole cluster. So that is important, so that every member can see a consistent view of the data. It is using XCOM, which is a Paxos implementation. So XCOM is developed by MySQL, and it's used in MySQL InnoDB Cluster as well. And this Paxos algorithm does all this replication, gains the consensus part of things, and do the conflict detection and resolution. A very important feature in 8.0 for MySQL group replication is that you can configure the consistency guarantees that you have. So the default is eventual consistency. So there's a big distinction we need to make here. When we have group replication, we have a guarantee that all members, so basically the replication part of group replication is Paxos. So there is a guarantee that when a member fails, when the primary fails, that where for a transaction that was committed already, the majority of the members have received it. So when one member crashes, well, the other members will be able to have that data as well. So replication happens through Paxos, but then the actual applying of the transactions on each of these members happens asynchronously. And with these consistency guarantees, the default is, okay, when I write something on one member and I commit it and I immediately read it on another member, the data might be retrieved that was committed on the other member, or it might not be. So it all depends on kind of the difference in time between them, how fast it replicates, if there's was any queue or not. Now, this is the default behavior, but in 8.0.14, I believe, or 13 or 14, you can configure this and say, I want, when I read something, I want to make sure that I read the absolute latest data. Or the other way around, when I write something, I want to make sure that before the transaction is committed, I get an OK back. Before I get an OK back, we need to ensure that all the other members have prepared and executed that transaction. So basically a two-phase commit happens then. So you can configure these consistency levels as needed on a session or a global level. So all of this in MySQL Group Replication is built on the MySQL Replication framework. So it's used, if you're familiar with MySQL Replication, we have binary logs, relay logs, global transaction IDs, GTIDs. All of this is used in Group Replication. So it's not some other technology. No, it's basically MySQL Replication, but another replication framework on same replication framework, but another type of replication on top of that. So it's easy to switch between group replication and regular replication. So we're relying on GTIDs, and mixing them is also possible. So MySQL Group Replication has been GA since MySQL 5.7, and we support all the platforms that MySQL supports. So let's take a step back and think about the business requirements. And this is important when we think about group replication, is that we have two concepts here. We have the RTO and RPO. So RTO is the recovery time objective, and this is how fast should a service recover from a failure. The RPO is how much of data loss can a service lose from a specific failure. So this is important to know, like, okay, what are the requirements of my application of this data? How much of this data can I lose? How fast we need to fail over? But what is important is that there's different types of failure. And we have failure in high availability, for example, is a single server is failing, or a network partitioning has happened. These we call a kind of high availability. We resolve this. If it's a full region / data center that fails, or the network between regions fails, then disaster recovery is another type of failure. And then we have a human error. For example, drop database happens by accident, or the application does a delete, but it forgot the where clause. It's some bug in the code. Also, we call this often like a little Bobby tables, kind of where the data is suddenly gone. Well, this type of failure is different. So when we think about RTO and RPO, it's easy to claim, okay, the business requires no data loss in any circumstance. Well, I think it's important we think about, okay, no data loss in case of single server failing. Maybe that's okay to have some data loss when a full data center fails, but not when a single server fails. So this is where we need to make this distinction on that. And how much data we lose, how fast we need to recover, all depends on these types of failures and are different. Now, if you say automatic failover, I can only be, I need to recover from a failure within a few seconds. That is possible with high availability. It is possible with disaster recovery, meaning that when a full data center fails. But having this within a few seconds, the recovery time is gonna be quite a complex architecture. And if we say like, okay, we want data loss no data loss when a single server fails. Group replication provides you that. But if you want have as a requirement, I do not want to lose data when a data center fails, okay, then we need to have a group replication configured differently, and we have to deploy it across data centers. And then we need to ensure, okay, we do not want any data loss. So there will be, for every transaction we commit, there needs to be a connection to the other data center to guarantee that the other members have received that. So all of this is possible, but it has an impact. So the more strict or the more requirements that you have, the more complex and more challenging a certain environment will be. So it's very important to know that. Now, if we channel this back to group replication, and the use cases is that group replication gives you no data loss when a primary member or any member fails. So this is a single member failing, right? If we have 3 members and 2 members fail, that's 2 failures happening. Then we cannot guarantee that there's no data loss. So that's important to know, because XCOM or this Paxos implementation guarantees that when we commit a transaction, the commit is only returned to the application as being done when the majority of the members have received it, not all of them. So that's why that's the default behavior, and that's why we can say, okay, when a single member fails, that's okay, we will not have any data loss. There's also built-in split brain prevention. So making sure that when there's a network partition, it's not possible for 2 members that cannot connect to each other, that are partitioned, that they will accept writes. No, only one group, one network partition site will accept writes, meaning the one with the majority. So the ones that have quorum. So if we have a 3-member group and one server is the primary one, in single primary mode by default is network partitioned, then what will happen is that it will detect that it's network partitioned. It sees only itself, meaning 33% out of 100, so 1 out of 3. And it will remove the fact that it's a primary. It will become basically unavailable because it has no majority. The other 2 that are in secondary mode, at that time, when the network partition happens, they detect, oh, the primary is gone. We have majority. We have more than 50%, not equals, so more than 50%. They will elect a primary between those 2. So that's why we recommend a 3 or a 5 node installation. So an uneven amount of members. Why? Because if we have a 4 members and 2 members are network partitions, none of them have majority. They both have 50%, meaning that there will be no primary. So you will have no availability at that time. So that's kind of a best practice in most scenarios. So failover happens automatically. So this network partition handling is automatic, all built into group replication. So there's no, when we mentioned Shell is a way to configure the group, configure InnoDB cluster, but it is not making any decisions. It just merely configures it. So all of this is handled by the database members themselves. A very good use case for group replication is this read scale out. So you can add and remove members as you need. So the replication lag, which I previously mentioned that is possible, is actually reduced heavily compared to replication because there's flow control built in, meaning that every member knows the state of the other members, knows how much lag does each member have. And depending on the configuration of flow control, it is possible that the member that is accepting some writes is delaying the writes or the commit of those transactions because another member is lagging behind, just adding some latency. So there's a lot of configuration settings there. So it could be like, oh, let's add a millisecond to this transaction so we can give some more breathing room for the slowest member to catch up faster. Because if I push a lot of throughput through one member and there's a member that is falling further and further behind, well, that's not what we want. We need to prevent. So hence this flow control. And as previously mentioned, we have these consistency levels, which we can configure to say, okay, I want read scale out, but I cannot have any stale read at any point in time. Well, you can do that. You just say, I want no stale reads. You say the group replication consistency level, you can set to various modes. We have before, and after. So we have various blog posts available that go into a lot more detail on how these work. They are quite advanced, but it can give you the guarantee, okay, no stale reads are allowed. And you can configure on a global level, or you can say, okay, for this session, no stale reads, but the other ones are fine. So you can configure all of this. So the other thing, last use case, is that active-active. So you can write to multiple members at the same time. We can guarantee the consistency. Writes are ordered within the group. The Paxos XCOM protocol will kind of arrange all this. And very good to know is that write performance in group replication is actually quite good. There is, when we write two transactions at the same time on two different members, during that transaction, there's like no exchanging of locking. So it's only when a transaction commits that there is any communication with the other members. So when we do a begin transaction, we do some selects, insert updates, whatever, it's all local. It's like a local MySQL server. It will be as fast as MySQL is, InnoDB, and so on. When we commit that transaction, that's when group replication kicks in. That's when, okay, before we can return the commit back to the application, we need to send this to all the members. And as soon as I have a majority that have acknowledged this, I can send an OK back. Now, it is this writes that are ordered. So the first one to write and to gain consensus in the group, so that one will continue. So if there's another transaction on another host that is conflicting, that is updating the same row, for example, then that one will be rolled back, and the application will get an error like, okay, this error in this transaction has been rolled back at any statement that runs or when it commits a transaction. So, so as soon as it reached the group and it reached majority in the group, it's considered to be part of the group. It will have to be executed, and any other transactions that are conflicting will be rolled back. Now, because of this happening only at commit, there is a very good write performance that you can have for these systems. Keep in mind that we can guarantee no data loss when a member fails, of course. And we have this automatic membership with consistency and no data loss. And so automatic failover and all these things, we can guarantee that. So we need to have one round trip to the other members as added latency at every commit of a transaction, not at every state. So let's talk a bit about router now, and router is the second part of it. And this is kind of the transparent way to get to the from the application to the database. So the application is configured to connect to the router, and the router will redirect to the group replication member necessary. So currently, MySQL Router is a kind of TCP-based load balancer. So there's a TCP port for primary traffic and for non-primary traffic, meaning that you connect your application to the primary port, it will always go to a primary member. So in single primary member mode, the default, you will always connect to that primary. In multi-primary mode, it will choose any, depending on the kind of the routing mode that is used. If you say I want non-primary traffic, then you will get a secondary host. So in single primary mode, the other members will be used for this traffic. So very important for us is that this is a lightweight service. It is best practices to run this on the application servers themselves. We have customers running with hundreds of MySQL routers just to one database at any given point in time. Oh, sorry. Very important is that it's little to no configuration needed. It's very lightweight, and important is that shell actually configures the group, sets some metadata in the database server, and a router will actually read that and listen on that, and it will know when members are added and removed. It will automatically learn that. When primary changes happens, the router will learn it. So router does not have much configuration. And as we are building router and adding more functionality to our products, it will remain stateless as much as possible, or even less. And we're going to move more and more functionality or decision making, at least, into the database side, so that the router will observe most of it. And then the third item is Shell. And Shell is this interface that the developer and DBA can use just to or sysadmin can use just to get a very powerful interface to set up this. So there's 3 languages that it supports: SQL, but also JavaScript and Python. So you can script, you can add your own extensions to it, plugins to it. It supports both document and relational models. Yeah, I'll give you some example on how this easy to use this is. So here's how we can create an InnoDB cluster. So we connect to Shell and it goes into JavaScript mode by default. And we're connecting user admin to host MySQL 1. So just over a MySQL connection, we are gonna create a cluster. So we're not doing anything local anymore. We're only using MySQL connections to do any operations to set up InnoDB cluster. So we have create a cluster object and say DBA create cluster with the name cluster. And we have a single member cluster at that time. Now, let's say we want to add MySQL 2 to it. Well, first we need to configure it. And we do this with DBA configure instance. We specify your username and a host name. And we authenticate, and it will configure the necessary MySQL settings in order to support group replication or InnoDB cluster. So, for example, binlog checksum needs to be none. The GTID must be enabled. If that's not the case, well, Shell will do this, and it will configure all this over a MySQL connection. If you're using MySQL 8, so that's very important. So InnoDB cluster runs on 5.7 and 8.0, but in 8.0 we added functionality to change configuration settings. So we have set global variable name, change it. But now we have in 8, we have set persist, which means change the running system and also persist it after restart. So it's basically updating my.cnf. So it's not updating the my.cnf itself, it's updating a kind of MySQL configuration file in the data directory itself, which it reads at start. And another thing that is some settings are not dynamic and you need to restart the server. Well, in MySQL 8, we have the restart functionality and you can restart the database by typing restart. And Shell leverages all these functionalities in MySQL 8 to really be able to do all this. So I can run MySQL Shell on my laptop, connect to some servers, so to MySQL servers, wherever it's running. Is it in Windows? Is it in a container? Is it in Linux? Somewhere else, far away? It doesn't matter. We can just all do it through this interface, provided you have the necessary permissions, of course. So we configure it. Now, when it's configured, the configuration is okay, but then we need to add the server to the cluster. And basically what we do is cluster.addInstance, and we say add it. And it will then add the instance, it will provision it when needed, it will make sure that everything's configured and up and running. And then we can also configure the router. And the router is as simple as bootstrap and start. Bootstrap meaning, okay, router, connect to the cluster, get the information you need to configure yourself so that you know how to connect to the group when you start and to find all the endpoints. And then you start router, and router starts to learn about whatever changes we happen in the topology. We can then check, and all the examples I'm using in the JavaScript mode, you can do the same in Python mode, for example, is that we can check the cluster status by cluster status, and we'll see, okay, we have the cluster here. The primary is MySQL 1 right now. We have MySQL 1, which is in read-write, and MySQL 2 and 3 are in read-only at this moment. So this is MySQL InnoDB Cluster, very easy to use. And just to give you a little timeline on the evolution of MySQL InnoDB Cluster. So Group Replication, the initial version was released back in 2014. So that's almost 6 years ago. And Group Replication became GA in MySQL 5.7.17 in December 2016. So that's when we had MySQL InnoDB Cluster. And you can see that at every MySQL 8 release, almost every minor release, we actually added more functionality. For example, we added more encryption things in 8.0.14. We added consistency, those consistency levels I mentioned in 8.0.14. Node provisioning was added in 8.0.17, and so on. So there's a lot of things we add, and we will continue to improve MySQL and MySQL Group Replication InnoDB Cluster as we make releases. So we've noticed that many of our customers in various sectors have adopted InnoDB Cluster, and they're running InnoDB Cluster in production for a while. And some of the things that you see, why are people using it? Well, the feedback that we get is, okay, we have this router that is fully integrated and it's easy to use. It's not complex. It's simple. It automatically configures itself and knows where the database is. It's very, very powerful. Shell is very easy to use, configuring, adding, and removing members. Shell really makes this very easy. And then, of course, the group replication architecture, because it provides this consistency, this automatic failover, network partitioning handling, guarantees no data loss, this automatic provisioning. So we've got really good feedback on InnoDB Cluster. But we know that a lot of people are still using replication, not group replication. And what we did in 8019 is introduce MySQL InnoDB Replicaset. So we take what was really good in terms of router and shell functionality, reuse the almost exact same commands to set up InnoDB Cluster, and instead of group replication as a database backend database architecture, we would have replication. Now, there's a lot of differences there. So in replication, we don't have automatic failover with replication. We have manual switchover and failover. So switchover meaning a kind of planned switching of a primary, and failover meaning failing over when something went wrong. So this gives you read scale out, but this is fully asynchronous read scale out. There's no guaranteed, no data loss. It does not guaranteed here. So this is asynchronous. So there's basically a version that people are used to run, but they had to configure themselves in the past, and not now anymore. So there's less requirements on network, for example, than group replication. It's not that group replication needs like a very, very low latency networks and high bandwidth. Well, it benefits from that, but replication does not need that. If, for example, there's a little, there's packet loss or there's no network for 10 seconds, well, group replication will be impacted by that. And during those 10 seconds, there might be membership changes, members being network partitioned. There will be transactions that are not committing, are waiting for this network partition to resolve or membership to change. Well, with replication, that's not the case. So it gives you a lot of availability, ease of use without all of these requirements. So let's compare a little bit what InnoDB Replicaset provides compared to what was in the past. So in the past, you had to restore a backup to provision a new member, a new secondary you want to add because you want to do read scale out. Well, with InnoDB Replicaset, members are automatically provisioned using InnoDB clone. You had to configure your own replication users, configure the replication yourself. Well, Shell all does this for you. It configures the configuration of MySQL, the users, generates passwords for you that are safe, secure, and it configures replication for you. You had to change your application configuration or whatever load balancer you used. Even if you were using MySQL Router to configure and to connect to regular replication, you had to manually or find a way or automate yourself some way to change this configuration. So with InnoDB Replicaset, the router is integrated. It knows and learns about topology changes with replication. So only bootstrap is necessary, and then router, stateless, it will adapt automatically to any topology changes. The next item is that, okay, how do we change the topology? Let's say a server crashed, or I want to make another member the primary because I need to do some maintenance, some patching on the current primary. Well, in the past, you had to do quite a lot of commands yourself or rely on external tools, not made by MySQL, to make these topology changes. So with InnoDB Replicaset, it's easy to use, just one command and Shell will do all this work for you. Very simple. There's no need to log in on all servers anymore to check the status of your topology. In Shell, you just check status and it will give you the status of the topology. So the whole thing is that with InnoDB Replicaset, we give a standardized best practice setup. We do everything we can to prevent mistakes, because in the past, the user was responsible for all of these steps. And all of this failures could happen, and some settings might not be optimal, and this and that. So with Replicaset, we try to make it easy, very important for us. So in the end, I consider that in the past, every setup is a customized setup. And now we have a standard solution that is supported and tested by Oracle. So very important. So every user that in the past was configuring an application had to do its own QA, its testing, whether or not this works, the failover works, the switchover works. Well, here it's important to test yourself when you deploy, but it has already been tested by us as well. So you'll run into a lot less corner cases than before. So no need for any other software or any automation. And what we've noticed is that there's a lot of companies that use some open source software or proprietary software to configure a replication and to manage the topology of it. But a lot of them might go beyond what the user needs. And or companies would hire consultants or managed services to do all this work. And I've seen a lot of over-engineering in a way that if we think about what are the requirements of a certain application and then see what solution was recommended, often, and this is what we try to bring with InnoDB Replicaset, is that, okay, you have all these solutions and all these services you can use, but you don't have to use this here. With InnoDB Replicaset, even for a MySQL beginner, we give you very easy to use, or even if there's not a lot of business requirements, like data loss is allowed, failover is manual, is okay, well, you can use it. You don't need to become an expert in MySQL for that, nor hire an expensive company to do so. So a little bit about the requirements and limitations, of course, is that, so for InnoDB Cluster, we support 5.7 and 8.0. Now for InnoDB Replicaset, we only support MySQL 8 because of the set persist, because of the node provisioning, and that's very important. Now, InnoDB Cluster works on 5.7, but you'll find a lot of better features, all of these features that I showed previously in this overview here. 8.0 is really, really a lot better, has a lot more functionality than 5.7, and is a lot easier to use with this node provisioning, for example. So InnoDB Cluster 8.0 is definitely what I would recommend. But for InnoDB Replicaset, it's the only solution that you have, basically. A limitation or a design choice is that it's manual failover, not automatic. And we do not plan on doing any automatic failover. If the RTO needs to be lower than manual failover, what you can achieve with a manual failover, then we recommend or suggest you use InnoDB Cluster. That's very important. Multi-primary is not supported through a classic replication because we cannot guarantee data consistency. And if we cannot, we will not provide such a solution. So we use InnoDB Cluster for that. There is currently only support for a single tiered replication architecture, not a multi-tiered. So you cannot have a primary and then replicating to a secondary, and then that one replicates to another secondary. So these multi-tiered architectures are currently not supported. So let's do a little demo, and I have some screencast prepared for this. So we have MySQL Shell, and we connect to, we start Shell, and we connect to a server. This is local host now, just have 3 servers running locally, but it could be anywhere. Keep in mind, it's using a MySQL connection to do all of these operations. So first, we'll create the replica set. And this is similar to the commands that I showed before, is that with Replicaset and cluster, the commands just vary slightly, but the overall experience will be exactly the same. So we do rs is the object we create Replicaset, and we call it a Replicaset, our cluster. So here we do status, and we can see, okay, we have a Replicaset called Replicaset, and there's one member, 3301, port 3301, which is the primary in read right now. So let's add an instance here. So we do rs add instance, and we say, let's add instance 3302. So what we get here is that, okay, this instance was empty. It had nothing, really nothing. So the GTID set was empty. So no transactions or anything. It just had a way to connect to it here. And have the permissions. And then what we see is, okay, it has no GTID set. So we cannot really know what the state this server was in. Maybe GTID was just enabled, but it already had some data. So starting to replicate from that is not possible. So we really suggest, okay, let's do a clone. So meaning we take a full snapshot and replace the data of localhost 3302. And that's what's being done here. So we can see clone is being done. It takes this physical snapshot of the primary, sends it, streams it to the new server, and takes a while. It comes up and everything up and running. So when we check the status, we can see that 3301 is read-write, 3302 is read-only right now, and this is the replication status. So it's replicating from 3301 at this time. Let's add another instance. So we're adding 3 to the mix. So it's restarting now, done. So part of it is that the server, when it clones, it has to restart. All of this will be done by InnoDB clone, actually. And Shell will monitor the progress and add the member and configure replication afterwards. So when we check the status, we basically have 3301 is read-write, then the other 2 members are read-only. So we have 2 secondaries now. So let's try some things. Let's do, for example, change the primary. So let's make localhost 3302 the primary. So it's as simple as that. Change the primary. It checks the status. Set primary instance is a switchover, meaning there was no failure. So it will not do anything if the status of the topology is not good. So this is only used when doing a planned failover. And we can see that it does kind of several steps to reconfigure the topology. And the 3303, for example, will now replicate from 3302. 3301 will replicate from 3302 now. What it will do first, it will lock everything on the primary, then make sure that the secondary is caught up, promote the secondary. So it will take a couple of steps and it will guarantee that there's kind of no split brain in between. So it has to ensure that, and Shell will take care of all these necessary steps. So when we check the status now, we can see that 3302 here is now a read-write and the other members are read-only. Let's do something more and let's kill the instance. So I'm just stopping MySQL on the primary. So as this is manual failover, no topology changes happen automatically. So this is group replication, it does happen. So a new leader would be elected in group replication, but not here. What we have here is that we have 3302, which is in state unreachable. And 3301 and 3302 have this error. They have an instance error called IO thread has stopped with an error. So it cannot connect to the master. It cannot find its primary because, yeah, we shut it down. So what we need to do now to fix this, let's assume 3302 died and we cannot get it back. We do this failover. And we say, okay, let's force the primary to be 3301. And that's it. You just run it and it will mark 3302 as, let's have a look, invalidated. So 3301 is read-write now online. 3302 replicates, is read-only, replicates from 3301 again. So these 2 are fine. But 3302 here cannot connect to it and the status is invalidated. Now it's not running, so nothing happens. There's no problem. But what we do now, let's assume that we start 3302. And important is when we use Router, Router will learn about all these topology changes. So now we start the sandbox instance, but here's a special case. And this is what group replication resolves, but that a replication with Replicaset does not resolve, is that we just started 3302. Let's assume it just came back magically again. The network issues have been resolved for that host. Well, 3301 is read-write, 3303 is read-only. These are fine. But 3302 came back. It's in read-write, but it shouldn't be. It's invalidated. It cannot accept writes, but it does. So it's giving you a warning. Hey, the server was invalidated. We need to remove it from the replica set. Very important. And it's not a primary, but read-only is off. So it's read-write. Accidental updates to this instance are possible and will cause inconsistency. So it's very important. Now, Router does a lot here. Router will not connect to 3302 anymore. It will know that. However, in some cases, as we cannot guarantee split brain in all scenarios, it is possible that if there was a network partition with 3302, but a application server with a router was also part of the network partition, it would still connect to that primary. So we kind of have a split partition that is more than just the database servers infected. So in that case, you could have that. Now here in this example, it is no inconsistency happened. How do we know that? Well, using GTID set, we can see whether or not the data is consistent or not. And there would be another instance error here of seeing, okay, this has more transactions than the current primary. So that means that, okay, there are some transactions that went through 3302. And you can then fix them before we add that member again. But in this case, everything's fine. And that's what will happen in most of the cases. So let's rejoin this instance. We don't have to remove it. We can remove it, but rejoin instance, meaning let's fix the state. Let's put it read-only. Let's configure replication because it wasn't replicating as well. So it is now read-only. It's replicating back from 3301. So all good again, everything's fine. So no inconsistencies, nothing in this case, everything good. Now, what we're going to do now is the next step, is we're going to look at router. So we're going to bootstrap router. So this is the only configuration of router that you need to do if you want to use default configuration. We say run as your router user, bootstrap root at localhost. So meaning check, connect to one of the members. You can specify any member you want. And then router will see what the status is, figure out what the topology is, configure itself, and it will like store the state in some JSON file here in var.mysql router. It will make a configuration. It will tell you how to connect and use router. So now let's have a look at the log file and show you some examples, some state changes. So let's start a router here. We're starting router. We'll see, okay, what router immediately did is connected. It figured out 3301 is read-write, 3302 and 3303 are read-only. So it knows the state. So let's go to Shell. And Shell is connected to just the databases, right? It cannot connect to the router. And let's change the primary. So I did a set primary here. So let me go back a little bit. Let's see if I can go up a bit. Yeah, so set primary instance 3302. So when I run this, oh, I think let me try to correct this. This is a bit weird, this interface. I cannot. Okay, here. Let's start over again because it goes really fast, this screencast. So we start router. We go to Shell, and Shell just changes the topology. So it just set primary instance and says, okay, localhost 3302. We'll try to make 3302 the primary. It does that, and immediately router will know, okay, 3302 is the primary right now. So it will adapt to this topology change. So if we then change it back to 1, we change it, and router will immediately learn this change. So that was it in terms of screencast. So it's very easy to use. So some more information about a router. So just bootstrap. It will learn. It will do health checks. It will, when you switch over, it will learn about it. And it has a lot of smarts built in. When topology changes happen, the router will learn about this. Even if there's a kind of network partition issues, it will really try its best to reduce the chance that it's connecting to an invalidated master. And so that's kind of what it supports. But let's go over the two products now and see how it works. Well, basically, to create a cluster, or a replica set, it's the same command almost. It's just create cluster versus create replica set. If we want to configure an instance, we have configure instance for InnoDB cluster and configure replica set instance for InnoDB replica set. Add instance is exactly the same. Bootstrapping of router is exactly the same. So very, very easy to use. So why are we doing manual failover? And I think it's important to think about this a little bit. What we do not want is to have to run another external monitoring process and have that external monitoring process decide which machine should be the primary, which would not. There's a lot of solutions that exist already that do this, but it does not solve all the cases. And in a MySQL Group Replication and InnoDB Cluster, we did solve the guarantee that there's consistency. We do automatic network partitioning handling a lot better than what these tools can do. So having this external tool decide can cause issues. It can cause split brain issues in many cases. And what we observe is that a lot of the production deployments, they might use these tools, but only to do manual failover, because a lot of companies have seen that if we do automatic failover, we have too many false positives. And with manual failover, we reduce this a lot. So because this management node, there are some various tools available, but some of them are good, some of them are great, really try to be really smart in decision making, but often they are not. So it's very important. Now, there's also this thing in MySQL replication called semi-synchronous replication, which is kind of like a plugin on top of replication. We do not support that, and this is a way to prevent data loss when a member change happens. But there's a lot of cases and a lot of issues with semi-sync that make things very difficult. And even with all of this topology combined, it becomes very complex. It has to be configured when a topology change happens and all this. And InnoDB Cluster solves all the cases that semi-sync actually solves and does it better. So here's an example. Let's assume we have one primary. So in the middle, they have the M, that's the primary. And then we have two secondaries. So the replication goes from the primary to the secondaries. We have two proxies, two app servers, and we have this management server. Let's assume there's a network partition between this management server and the secondary. What will happen? What does that tool need to decide? And okay, this is maybe an unlikely thing to happen, but it can happen. And what will happen is this tool will automatically, some tool, I'm not saying that all these tools do that, but a lot of these kind of failover tools will make this decision. They will promote the secondary to become the primary. But it cannot invalidate or do like fencing or any stone it of that old primary because it cannot reach it. So what will happen is you'll end up with two masters that are automatically created two masters. So this potential split brain can happen. So we can see that the proxies still connect to the old primary basically. Now, okay, this is a problem because now we have two primaries and we create a split brain. So semi-sync is often recommended to solve some of these cases. So you could say, okay, this old primary will not acknowledge, will not acknowledge any transactions that have not been received by at least one replica. Well, that's the default. Well, there is one replica. So this secondary, okay, we need to have acknowledged from both of those to be able to be fail-safe here. Okay, but then any little network glitch will cause downtime forever. You want to put the timeout to unlimited, which is an option you can set. Or you want to say after 2 seconds, please give up trying to be semi-synchronous and go back to asynchronous. So there's a lot of configuration settings with semi-sync possible, but really InnoDB Cluster and Group Replication resolve these things for you. So I would not bother looking into semi-sync. I would really look into InnoDB Cluster if you want to have no data loss or have a guaranteed consistency when these failures happen. So Group Replication will handle this a lot better. So which solution should you choose now, right? And so if we think about InnoDB Cluster and Replicaset, so obviously InnoDB Cluster is a lot more advanced, has a lot more things automatic. but it might appeal, depending on business requirements, that Replicaset is a better fit. So it's up to you. And we give the same experience to configure and manage this, the same features with Shell, with Router, and we would try to really make it really easy to use for both solutions. So we have single primary mode. If you only want that, then both solutions work. When you want multi-primary mode, then you need to use InnoDB Cluster. If you want to do a read scale out, both solutions give you a read scale out. But if you want consistency guarantees, like I want consistent reads for this one, then you need to use InnoDB Cluster. In InnoDB Cluster, all members are part of consensus. So keep in mind that your write performance is basically as fast as your slowest node. And for every transaction you commit, there is a network overhead. So one round trip to the other members. With InnoDB Replicaset, that's not the case. It's fully asynchronous, and the secondary members, they just get this stream of changes of the system. So they do not impact the primary at all, or any network partition does not impact the primary. So that means that a stable network is really required for InnoDB Cluster. So any network glitch will cause stalls or membership changes. And hence we also, because of this quorum and this partition handling, an uneven amount of members is recommended. 3 or 5 is generally the recommended way. And for InnoDB Replicaset, there's no thing that impacts the network issues between primary and secondaries. And you can run on 2 members, that's fine. Of course, you will not have this automatic failover and all of these things, but that might be important. So no data loss in case of a member failure. So RPO is 0 in case of a member failing. And we have this consistency. And InnoDB Replicaset, during a planned switchover, no problem, no data loss, no split blame, everything is handled. But when you do a failover, so an unplanned event, something failing, then it's up to you, because you do it manually, not automatically. Manually, you decide what's going to happen. You can take the measures manually to make sure that there's no split brain, or you can accept it or not. It's the balance you want to make. And then, of course, automatic failover is InnoDB Cluster. So RTO, the time to recover, is going to be lower with an automatic failover than with a manual failover. But of course, it could be that if you have an unstable network, there's a lot of failures and a lot of members moving away, being primary and going away and whatnot. So yes, a single failure will be fast to be handled, but the overall time of all these kind of failure cases might add up and affect your global uptime as well. So manual switchover is for InnoDB Replicaset. So that was it. That was the presentation. So there's a lot of websites that I recommend you to read if you want to learn more. We have, of course, MySQL.com. We have our documentation, but then we have 2 important websites which we push a lot of blogs. So the engineering team at every MySQL release puts in various blog posts that gives you a lot of technical details, design, how to use on every feature we add. So it's MySQL High Availability.com and MySQL Server-team.com. So if you have any questions, just post them on the QA and we'll try to answer them. Thank you very much. Thank you.